Hi, this is your Professor Sudha Kolathuparambil, partial derivatives. First, consider a function of two variables. Suppose we fix y at 2. Then this function will become x comma 2 and this y will be 2. Then this y is 2 again. Okay. Then simplify. Then if you differentiate with respect to x, we will get 16x plus 10 because derivative of x is 1, derivative of 12 is 0. So in general we can say we are replacing y with a specific number. But we don't know, it could be 2, 3, 5, in any number. That means we can say y is fixed. Y could be any constant. Then the function f become the function of x alone, right? Then if you calculate the derivative with respect to x, this is called the partial derivative of f with respect to x. And we usually denote that by like this, or the function f of xy we can express as z equal, we can write z equal f of xy. So you can write in this notation, partial derivative of z with respect to x. So this is the partial derivative of f with respect to x. So this is the notation for that. So let's go back to the previous question again. We are not replacing this y with a constant, but we are treating y as a constant. So treat y as a constant and differentiate with respect to the variable x. So we can write the partial derivative of z with respect to x is, here y is a constant, so constant times the derivative of the function. So this is the only function, right? So derivative of that is 2x. So the constants stay the same. Let me mark the constant here. So this is a constant, y is a constant, so these two are constant. Oh, this whole thing is a constant, right? So if you take the derivative, so 5y is a constant, so derivative of x is just 1. Derivative of 3y is a constant, so derivative will be 0. So the answer is 2xy cube plus 5y. Let me explain this partial derivative again with a simple example. So z is 2x minus 3y. We need to find the partial derivative of z with respect to x and partial derivative of z with respect to y. Partial derivative of z with respect to x means we are treating the other variable other than x, that is y, right? So treat y as a constant and differentiate with respect to x. So derivative of 2x is just 2. Derivative of 3y is a constant because we are treating y as a constant, so that will be 0. This one partial derivative of z with respect to y means we are treating x as a constant and differentiate with respect to y. So x as a constant means this 2x is a constant, so derivative is 0. Derivative of 3y with respect to y is just 3, so there will be minus sign in front of that. So 0 minus 3. So the answer is negative 3 for this one. This will be 2. Another notation for the partial derivative is like this. So this one we can write f of like a subscript y. If the function is given like f of xy equal to 2x minus 3y, so we can write first partial derivative with respect to x, we can express in this notation, or the first partial derivative with respect to y we can express in this notation. Higher order partial derivative. So first partial derivative with respect to x, this is the notation I just explained. We can differentiate this again with respect to x. So this will be second order partial derivative, and we can write this as with 2x's at the bottom, like as a subscript. And this one, if you are differentiating with respect to y again, this is the notation for that. Or we can differentiate this with respect to x, right? The same thing we can differentiate with respect to x. So we will express that as, because first we are differentiating with respect to y, then again we are differentiating with respect to x. Same way we can take the partial derivative of this one with respect to y. And the notation for that is f and subscript xy, because we are differentiating with respect to x first, then we are taking the derivative with respect to y. While we are differentiating with respect to x, we are treating y as a constant. While you are differentiating with respect to y, we are treating the x as a constant. So you can think whatever the variable we are differentiating with respect to, treat the opposite other variables as constant. So if you are differentiating with respect to x, here treat the other variables as constant. In this example, we need to find the first partial derivative. So first we will find the partial derivative of f with respect to x, treating y as a constant. So while taking the derivative with respect to x, there are two functions here, right, f and g. So we need to use the product rule. So f prime g plus f g prime. And remember here y is constant. So derivative of f is 14 and g, that is just ln of xy, plus f, that is 14x. G prime, the rule is if you are taking the derivative of ln of u, that is 1 over u prime, right, the chain rule. So we need to apply that rule. So g prime will be 1 over u, instead of u we have xy, right? So 1 over xy times the derivative of xy, but here remember y is a constant. So 1 over xy times derivative of xy, if y is constant, it will be y times constant times the derivative of x, right? So derivative of x is just 1. So this is just 1. So you will end up with just 1 over xy times y, this y will cancel. So that is just 1 over x. Now you can simplify that and write. So 14 ln of xy, oh, this x will cancel, right? So plus 14. So that is the first partial derivative of this function with respect to x. Now let's find the partial derivative of f with respect to y. So we will treat the other variable, that is x, as a constant and take the derivative with respect to y. So x is a constant, so this is a constant, and here this one is also a constant. So this derivative become constant times the derivative of a function. So this whole thing is a function, okay? So this will become constant times, so 14x times the partial derivative of ln of xy with respect to y. So 14x, here x is a constant, so if you want we can do that separately. This is the rule I am applying. Derivative of ln of u is 1 over u prime. So this will become 1 over xy, instead of u I have xy, then you are differentiating with respect to, oh, we are differentiating with respect to y, right? So dy, but it is partial derivative, so I cannot write d over dy. It's like a curly d, and differentiate xy again with respect to y. So differentiate xy again with respect to y means we are treating x as a constant. So it will be constant times derivative of y with respect to y. Derivative of y with respect to y is just 1. So it will be constant times the derivative of y with respect to y. So that is just 1. And this x will cancel. So the answer is 1 over y. So this will be times 1 over y. So 14x divided by y. And here remember that as long as the variables are matching, that is just 1. So if you have partial derivative of y with respect to y, that is just 1. If you have partial derivative of z with respect to z, that is just 1. So as long as the variables are matching, remember that that is just 1. In this example, we need to find the 4 second order partial derivatives. So first we will take the partial derivative with respect to x. Then again we will take the partial derivative with respect to x. So take the partial derivative of this with respect to x by treating y as a constant. So if y is a constant, this will be constant times derivative of the function. So derivative of x square is 2x. Y square still stay the same because that is a constant. Here y is a constant, so y will be still there, and take the derivative of this, that is 4x cube. And e power y, that is a constant, derivative of x is just 1. So that's why we didn't write 1, because 1 times e power y is just e power y. This is actually first derivative with respect to x, this whole thing. Then we need to take the derivative of that with respect to x by treating y as a constant. So this is a constant. Constant will be still there. Derivative of 2x is just 2. Constant will be still there. Derivative of 4x cube is 12x square. This is a constant. Derivative is 0. So this is the second order partial derivative. In this question, we need to differentiate or take the partial derivative with respect to x first, then y. So while writing in this notation, we are reading from right to left, but this one we are reading from left to right. So first we will take the partial derivative with respect to x. So that is same as the previous one, right? Now we need to differentiate with respect to y by treating x as a constant. So here x is constant. So when you take the derivative of this with respect to y, 2x is a constant, constant times derivative of y cube. Derivative of y cube is 3y square, right? So 2 times 3, that is 6x y square. Then 4x cube, derivative of y is just 1. And e power y, derivative of e power y with respect to y is just e power y. In C, we need to take the second order partial derivative. First, we need to differentiate with respect to y, then differentiate with respect to x. So, when you differentiate with respect to y, we are treating x as a constant. So, constant, that is here, derivative of y cube is 3y square. Constant times derivative of y is just 1. Constant, that is x, derivative of e power y is e power y. So this is the first derivative of f with respect to y, treating x as a constant. Now we need to differentiate with respect to x. While differentiating with respect to x, the other variable will be constant. So these two are constant. So derivative of 3x square is 6x, and y square will be still there, that is a constant. And derivative of this with respect to x is 4x cube. Derivative of x is 1, and this is a constant. So constant times derivative of function, that is how we are doing this. So this is the second order partial derivative by differentiating with respect to y first, then differentiating with respect to x. Fourth, second order partial derivative is we are differentiating with respect to y first, then again differentiating with respect to y. So differentiating with respect to y, that will be the same thing. Then again we need to differentiate with respect to y. While differentiating with respect to y, we will treat the other variable as constant. So these are constants. So constant times derivative of the function. Derivative of y square is 2y. Then multiply, you will get this. This is a constant, so derivative is 0. This is constant times the derivative of this function with respect to y, that is just e power y.